To be doing today. I'm going to show you exactly what it is, and then we can go ahead and talk about how we're going to do it without any codes, and then we can go into the coding part. So this might honestly be about like a 2 or 3 part uh like series, I guess, of how to draw the snake, because there's like a lot involved and I want you to understand everything. So let me just change something really quickly. I'm gonna change this to 10. Sorry, I want to change this to 5. Just because I know that I can't for some reason play this game that well, so I need to go slower. Okay, but you can keep it at 10, and you should. All right, so here we go. Right now, notice that as I am eating the snake, okay, do you see what's happening as I'm eating the snake? So you should start to. As I'm eating the snake, as I'm eating the apple, it's starting to grow. Okay, and every single time that I eat the apple, it is growing. So that is what we're going to be doing today. Okay, and how would we do this? So I'm just going to just exit this out, right? And I'm going to try to explain it here. So let me just grab my pen really quickly. Okay, so I'm going to try to explain it here, and the way we're going to do this is, let me just make sure I bring all this to the front and I make sure the float on top. All right, is I want you to imagine that this is the snake right here. So I'm going to go ahead and get this. Let's say that the coordinates of this starting point is half of the width and half the height. So let's call it 300, and let's say it's 400. Okay, so this is your x and this is your y. Remember that here we start at 0, 0. Okay, going this way is our x, and going this way down, it will be our y. Okay, that's how it increases. All right, so if you had pressed the right arrow on this key on your keyboard there, then it would actually go up by 10 pixels. Okay, I changed mine to 5 just now because I needed it to go slower. But since yours is 10, we're gonna use that. So if it's going to the right, the new coordinates for this, okay, is going to be 310 comma 400. Because remember, the computer doesn't know that you're trying to like move a snake. It just displays the pixels at the location that's needed. So in the beginning, we were displaying at 300 comma 400, and then when you pressed when we had checked for the event and you pressed the right arrow key, it added 10 to the x axis, or the x rect, and it became 310 comma 400. So at that particular second of a frame, it displayed it there, right? And that's why it looks like it's moving, but you really just displaying a new image every single time. Okay, and similarly, this would be 320 comma 400. Okay, so what we're going to do is to add a length to this. Okay, again, it doesn't know that when you eat an apple, as we've clearly seen, that it needs to add a length. We need to write the code for that. So the way that we're going to do that is we're going to put everything in a list. Okay, but and specifically what we're going to do is we're going to have a list that's going to attach or append the x and then the y. So and then so like imagine that we're taking all the x's, right? Or rather, every single like millisecond, we're taking the x coordinate, putting it in a list, taking the y coordinate, putting it in a list. So we're gonna have something that looks like this. I'm gonna create a list that looks like this: snake coordinates, and it's gonna be an empty list, okay? And then what we're gonna do is, let's assume that we are here, okay? That the first box, it's going to append. Now, when you append something, it goes in always at the end, right? So I'm going to append 300. Then at that same instant, I'm going to append 400. Okay, like that. Now, if I were to continue this, then the next one would be 300, comma 400, comma 310, comma 400. Okay, and that would represent if we added this box. So this is what it would look like if I attach the x and I attach a y. This is what it would look like if I then attach that second position, right? It just increases the length of my list. It'll just go on huge forever, right? And we don't want that. That's not cool. So what we're gonna do is that in the middle of this, and let me see if I can just draw this. In the middle of this, oh, can't do that. We're going to actually take this piece and we're going to attach it there. All right, and every single time that we do an x and a y, we're going to just attach that. So the first element is going to say 300 comma 400. Okay, and notice that it's being attached as a tuple. A tuple means like it's being attached right here in the parentheses. It's not, I can't change it the way it is right now, okay, but it's being attached as a coordinate right now in this new list. So it's like I attach an x, I attach a y individually, and then once I reach these two, I'm just going to take the whole thing and just attach it to the list. So let me just get rid of a couple things here because this is starting to get a little bit messy. Right? We don't want to be too messy because then it becomes hard to see. Okay, so we'll just erase this, right? Then we're going to do a new x and a y, and then we're going to attach this. So this becomes one element, 310, 400. All right, and then if we were to continue, 320, 400. Right now, at this point, let me just 330, 400. 400. Okay, now once we get to this piece, this snake list is going to get exponential, or not exponentially, it's actually a linear, but it's going to get incredibly big, right? Very, very huge, goes on forever. So what's going to end up happening is that we're going to have a snake list that is much bigger than the actual length of the snake, right? Because every single time that it's moving across the screen, it's going to be adding on all of these coordinates, even though we may have only eaten the snake, the apple, like once. Okay, so we need to have like a barrier there that's going to say, you know, if the length of the snake is this size, then only keep these amount of elements in there. So like if I have a snake that's two boxes long, okay, I only want to keep two elements inside of this list. But which two elements? Okay, now if you're appending something on, which one of these elements is going to be the most recent one? Okay, so remember that we started here, then this was 310, 320, 330. So these two are the last two coordinates. Okay, so the way we're going to do this is that every single iteration it's going to check and it's going to say, okay, how long is the length of the snake? Or you're only 2 pixels, or in this case, let's just say that it was 3 apples this guy ate. So let's say that he's actually 3 apples. We'll just make 3 right there. Okay, then just delete the first element because this first element here is going to be the farthest one back. That's the one all the way at the end that we've already passed a long time ago, and only keep these 3 coordinates. All right, so let me just show you how that's gonna kind of look like, and then of course we'll continue in the next video. Now I know that this is just a lot of numbers. As I start to write the code and I integrate and refer back to the numbers, it's going to be easier. So we have snake boundary. All right, we're going to be in our snake class, and we're going to create a new method. I'm going to call it track snake coordinates. All right, and pass self. Okay, and this is going to say keeps track of the coordinates of the snake. Now, I know this is kind of like, why am I even typing this? Because the name of my method was like already told you exactly what's happening, but it is what it is. All right, so first thing is, let me see if I can just make this smaller here. I'm sure I can. So I want to be able to refer back to it like a little bit, you know? Okay. And we really don't need all this space. It's not like a long piece of code. Okay, so I'm hoping you can see that. All right, so we're here, track keep the snake's movements. Whoa, where's my stuff? Okay, the first thing is that we needed a list to store these guys. So I'm gonna make a list here, snake cord equal to an empty list. So this is just an empty list, right? And then from there now, I'm going to attach the x coordinates. So that's going to be snake cord dot append. Okay, we're adding it. And what are we adding? The x coordinate, which is going to be self dot rect dot x. Okay, Then we're going to then do snake cord dot append self dot rect dot y. So here we are adding the x coordinate. Okay, CORDINATE, and then we'll add the y coordinate. Ooh. All right, and that's what that's gonna look like. So you know what I'm going to see if I can do here? I'm going to actually do this, and you don't have to do this. I'm just gonna do this because I want to see if I can just show to you really quickly. Hold on. So I'm going to just come down here and I'm gonna write self dot track snake coordinates so that it's there, and at the bottom, at the very bottom, what was this called? Actually, not the very bottom. I'll just do it right here. It's gonna look crazy, but let's just see. Hopefully everything does not freeze. All right. Okay, so notice where I am right now and going there at the end. All right. Actually, I shouldn't have done that. Hold on. Snake cord. Oh, okay. All right. So here's the thing that I wanted to show you. What I want to do is this. So you notice that like as I'm going to the right, okay, the coordinates are changing. Okay, but what I really want to show you was something else. Now, what I thought was going to happen was that every single time that I was going to the right, it would add on, add on, add on, but it wasn't. And at first I didn't understand why, but then I realized that when it calls this function, okay, yes, I am adding an x and a y, but I'm also, every time that we call this function, I'm actually resetting the list and making it back blank again. I'm clearing the list, and then so I'm only going to ever add one x and one y. Okay, so what I'm going to do is this. I'm going to go to the top here, and I'm going to do self dot, let's do snake list equals to blank. So this is going to be our empty list to store snake coordinates. So I'm going to come back down here now, and I'm just going to do now snake self dot snake list dot append snake cord. And you're probably wondering like, what the heck, why are we doing that? Got you. And what I'm going to do is also this. Actually, I'm not going to do this. I'm going to go down to the bottom. So I know it's a little bit staggered right now. It's because I'm thinking on the top of my head how I want to show you this rather than just do it. All right, so I'm going to come down here and I'll do let's do player dot snake list. I will print that. Okay, you don't have to copy this part down. All right, let me see if that works first. Okay, so check this out right here, okay? Whoa, okay, so check this out right here. Look at this, look, just try to see if you can understand this craziness. Actually, you know what I'll do? I'm gonna restart the whole shell and then we're gonna do it again so you can see it. All right, and there it goes. All right, so look at this now. We have 300, 400, 300, 400. Now this is all the same because we are not moving at all. Okay, now I know this is a little hard, but right here is where we start to move. So 300, 400, that was our x and our y. Okay, my screen froze. I knew that was gonna happen. 310, 400, 320, 400, 330, 400. That makes sense because if you were to pause and rewind this, we were actually going to the right. And so our x values were increasing as we went to the right. And the way that this code works is that if we come up here now, okay, I'm gonna have about another minute before I can't upload this anymore. It was past 15 minutes. Let's see. The way we did this is that we added our x, right? So this is our x. Then we added our y. Then we took both of them and added it to a new list, and those became coordinates. So I'm gonna pause this and I'm gonna try to make another video to better really explain this, because this, I think, it might be the hardest part of the entire program, is understanding how to make it this snake grow longer. All right, so I'll see you in the next one.